All right, so hi. Just a brief intro about us. I'm Thomas. I'm the engineering lead at LocalStack, manage the engineering department and execute our roadmap. I'll be moderating the event today and I'll also do a quick tech demo on our LocalStack CLI. With me today are Gerta Shigenako and Waldemar Hummer, my co-founders of the company behind LocalStack, and also our DevRel Harsh, who will be talking a bit about the community efforts. So Gerta will take over afterwards, tell you a bit about who we are, LocalStack, our journey, and later towards the end of the presentation, a bit about how you can scale your enterprise with LocalStack. And Waldemar Hummer, our CTO, will also talk a bit about cloud development using infrastructure as code on LocalStack, and also show you some tech demos. The agenda for today, just be a quick intro that we're doing now. We're going to do a bit of audience participation. I'll have a slide on that in a second. As I said, we'll talk a bit about who we are as an organization, as a company. We'll have some tech demos. We'll show you a bit of advanced capabilities and use cases. And we'll tell you about our efforts to build out the LocalStack community. So we want to keep doing these events. This is obviously our first event, so it's sort of a kickoff. But moving forward, we want to build out this community and also hear from you folks from the LocalStack community. And I'll talk a bit about that towards the end of the presentation when we do our wrap-up and Q&A. So as I said, we'll do some audience participation via slido.com. So if you have your browser or your mobile device, please go to slido.com, type in this code, and you'll be able to see the Q&A and the polls once I create them. So we want to learn about you. I've introduced our speakers today and a bit of us, and we want to hear about you as well. So especially what your role is and how you're using LocalStack. We'll talk about that later. So feel free to join on Slido and start voting. It's very interesting for us to see whether people are using LocalStack to learn about cloud development, whether they are using it to actually fuel their engineering workflow at the organization. For engineering managers, this is an interesting opportunity also to learn about how you can increase the productivity of your engineering team. We have educational licenses, so it seems that we don't have a lot of people in this audience. I come from an academic background, so educational licenses are very dear to me. We have an educational license program, so if you are from a higher education facility or you know someone, feel free to direct them. You get LocalStack Pro for free for a few months. Okay, so seems most of you all are professional cloud application developers, which is great because this is our main audience. Good. So another question that we have prepared for you is what your experience is with LocalStack. So are you new to LocalStack? Have you maybe downloaded LocalStack before and played around with it? Have you been using LocalStack professionally? So are you using it in your day-to-day engineering workflow? Or is your team using LocalStack? So we know from big organizations who have hundreds of engineers that use LocalStack day-to-day. Or is your organization already using LocalStack? So it seems the majority is sort of professional cloud application developers, but are mostly new to LocalStack or have been playing around with LocalStack. So this is very good. This is since this is our first community event, we'll tackle some of the basics. So I think for this audience, we have prepared a very good mix of content and tech demos. All right, so I'll hand over to Gerda now to talk a bit about who is LocalStack and who is behind LocalStack and what is our journey.
Thank you, Thomas. So awesome. So just to give a quick intro to the company, who we are and what we're doing. So basically LocalStack is a company in the developer productivity space. We've been around now for a couple of years, actually around 5 to 6 years, but mainly in the open source space and not too loud. And just in the last 6 to 9 months, we've really ramped up our engineering efforts, and we're supporting more and more customers. So over the years, we've really gained a lot of traction. We have over 39,000 stars on GitHub. We have over 84 million Docker pulls in total, and over 10,000 people who are part of our LocalStack community. If you don't have access to the LocalStack community yet, there will be a QR code at the end of the presentation, but you can also always request to join via email at info@localstack.cloud, or once you basically download the LocalStack Pro app, you also get an invite to join our community. We are generally a very international company, currently based out of Switzerland. Thomas is in Austria. Harsh, our DevRel, is based out of India, and we're also having a very mixed customer base. So our customers are really from across the globe, from different sizes of organizations, anything from startups to larger global Fortune 500 companies. And the main use cases that we really see our customers driving with LocalStack is this migration to the cloud. So everyone that's really starting to migrate their services and wants an easier route on how to do that. And obviously also very cloud native organizations that just want more efficiency in their development flows. On GitHub, we basically, as I said, we started around 5 to 6 years ago. We had a bootstrapping phase at the beginning where we just started ramping out and exploring the space. And since the last year, really, we are in this growth phase now. So everyone who has been using LocalStack maybe for longer, just a side note, I highly recommend to give it a retry because it has changed a lot along the way across basically all scales, so from functionality and features to startup times and so on. So just to give a quick overview, in the last 6 months, we've really been able to improve the performance and startup time from 10 seconds to less than 1 second. A new plugin system, support multi-arch builds. For example, if you're using an Apple with an M1 processor, we have advanced persistent support now in our product, and also a completely refurbished web user interface, and also desktop app that we just recently launched that I will touch upon later in the presentation. So really, we've turned from a popular open source project now into a company, and very excited to tackle the problems that we see in the cloud developer space. So as most people here are cloud developers, I think you know the pains that are associated with basically developing your applications for the cloud. So what we see very often is that people get very excited about the new capabilities that come from the cloud from a perspective of operational excellence. So the cloud really allows us to execute very fast, to scale very fast as an organization. But the problem is that those managed services don't really come with very developer-friendly ways of developing your application. So as a developer, after a while, you really see that the entire process is very slow. You often have to deploy, redeploy things into the cloud, wait for basically everything to execute until you get a result. The results that you get are not very reproducible, so you're struggling with the reproducibility of your development flows. So basically having to deal with log files that are coming in and so on. So another thing that we see is that it's often very blocking, so it's very difficult to set up the right amount of test environments and have them really kind of as ephemeral environments to just spin them up and down and test and start them up as you need them. Another thing that we very often see with our customers actually is that there are a lot of restricted environments as well. So in large organizations, there are a lot of gatekeepers that really prevent innovation in the cloud, that really slows developers down a lot. And it's not only the developers that are struggling at the end of the day, it's also a cost perspective for everyone that has to handle finances with basically more test environments and in general resources that need to be managed. It's a strain on QA on one side, but also on the cost perspective on the other side. So QA is really struggling with having those reproducible environments where a lot of testing is done very early on. And on the other side, talking about cost, there's actually an estimate that shows that around 35% of cloud resources are idle. So they are unused. We pay for them, but they're completely unused. So there's a lot of cloud waste going on out there, and that's something that we also really want to tackle with LocalStack. So our general mission at LocalStack is to give developers back control over their environments, free them from wasting time with inefficient development and testing loops. Just a bird's eye view, how does LocalStack work? So most of you already know LocalStack. We basically offer you the entire AWS APIs in a Docker container that you can run simply on your local machine and in CI environments and basically across your entire CI/CD pipeline. This really allows for very rapid development and testing on your local machine or wherever you currently are in your environment, easier debugging, and really just faster feedback cycles for your application development. What we're focusing more and more on now is also more advanced collaboration patterns, where there are persistence mechanisms that we offer that really let you do collaborative debugging on the same application state with other colleagues that you may have. As I said, LocalStack really ships as a very simple, easy Docker container. We support over 60 APIs now. Everything from compute to various databases, messaging like SQS, Kinesis, and so on, and also some more exotic APIs, like QLDB, Athena, Glue, and many more. And from that over to Valdemar and Thomas again for the really exciting part, the tech demos.
Yeah, thanks, Greta. I'll do the quick intro. We have another bit of audience participation because what we're interested in is also to learn what LocalStack version you're using. So here's another poll. Please head over to Slido and fill it out. So we have, as you know, the community version, which is completely free. We have LocalStack Pro, which costs a bit of money, but has these extended features, and we're adding new team collaboration features to that. Some of which we'll show an extended emulation. And we also have an enterprise offering for organizations. Okay, so seems most people are content with the community version. Interested in the Q&A later to hear about your thoughts, whether LocalStack Pro will maybe have some benefit for you. We're going to show a mix of demos from both LocalStack Community and a couple of Pro features. But yeah, I mean, this is good. This is the LocalStack Community. So we also hope to get people involved in LocalStack development. And obviously, we're at our heart is an open source project where everyone can contribute. And so it's good to see that people are engaging with the community version. All right, thanks, folks, for voting there. I'm going to just briefly get us started, get us warmed up, and then I'll hand over to Valdemar for a bit more interesting stuff. What I want to show you is our CLI, the latest version of our CLI. As you know, if you've been working with LocalStack, there are different ways that you can start up LocalStack. Most people, from what we learned so far, use some form of Docker Compose templates. We have a Docker Compose as part of our open source repository, so that you've probably seen. So this is just a Docker Compose file that contains a basic Docker configuration for spinning up a LocalStack Docker container. Obviously, this involves a lot of manual work, and probably you don't need to use Docker Compose at all, because we have a CLI that you can use, which you can just install. If you have Python on your local machine, you can just run pip install LocalStack, get the CLI. We're planning to make this easier in the future to download a dedicated LocalStack binary, so watch out for that. Once you have the CLI, you can just see whether it works. So I have the latest version running now. And it's a really easy way to start. LocalStack is just running start -d for detached, so that will start LocalStack in the background, and then you have your terminal back for you. And that's it. If we inspect the Docker daemon, you can see that the container is running. There's no configuration needed, no port, no mucking about with port configurations or anything else. So LocalStack CLI will take care of configuring the container for you. Right, and we can query the status of LocalStack. You get some information about the container, which version you're using, and we also have the service status. So you can see here that this is a question that we've been getting recently, is that people are waiting for their services to run. Actually, if the services are in the state available, they are essentially running. So we have a few versions past, we've introduced the service lazy loading. So when you first query a service, it will boot up in the background. This drastically increases LocalStack startup speed. So if you, I just executed a SQS command, and you can now see that SQS service is actually running and operational. A feature that I want to show you that you're maybe not aware of as a CLI, because we've introduced it recently and haven't really talked about it much, is the run configuration profile. So as you probably know, LocalStack can be configured with mostly environment variables. That's our main vehicle for configuring. And there's a very comprehensive list of configuration variables in our documentation. And oftentimes you have sort of compositions of configuration variables. So I personally, since I'm a LocalStack developer, I use a lot of the developer configuration. And if you look into the .localstack folder, obviously depending on your system, this will be in different places. But there are environment files. For example, in this case, this environment is called dev. And it just contains, like, sets debug to 1 and sets the log level to trace, and turns off the SSL certificate. And if you want to use this configuration with LocalStack, you just add profile equals dev, and then you can start up LocalStack with this configuration profile. So this is a convenient way to also switch between different developer environments. So often when you interact with our support, they ask you to enable debug and show us your logs, and you can easily sort of group configuration profiles. You can access the logs with LocalStack logs, and then you get access to the logs of the running container. So that's an easy way to get started. LocalStack CLI is very convenient to just boot it up. We have Gerda already hinted towards this. We have another product in the pipeline, the LocalStack Cockpit, which gives you a desktop experience of this. But I think that's it for getting started. I'll hand over now to Valdemar, our CTO, to get into the guts of the more complex scenarios.
Thanks a lot, Thomas, for sharing this intro. So this was really kind of the first steps of using the command line interface, using the profiles, and sort of starting up LocalStack, basically. So what I'll do, I'll just quickly share the slideshow here. Talk a bit about how LocalStack integrates with different tools. So what we want to show is, and some of these tools may sound familiar to you, for example, Terraform, a very popular infrastructure as code framework, or the CDK, the Cloud Development Kit. And I think it also has been mentioned in the chat before that people have been using CDK with AppSync. We actually have a demo exactly on this part. So just kind of showing a bit how LocalStack experience integrates with these particular tools. Terraform, in a nutshell, is an infrastructure as code framework by HashiCorp. So it is essentially a way to define your infrastructure configurations as templates, as sort of declarative sort of resources. And then what Terraform does is it first kind of creates a plan, like how should these resources be deployed into the cloud system. And then this plan actually gets applied to the real clouds. Fortunately, it's relatively easy to use Terraform with LocalStack because we're essentially sort of API compatible and we're providing the same APIs as AWS is doing, right? Without much further ado, I'll just quickly switch over to a short demo. So just stop the full screen mode here. So what we have here is a Terraform script. So this is what Terraform looks like. First of all, the first section we see up here is the provider section. So this is typically a way to configure the endpoints. So you can sort of point LocalStack, or you can point Terraform to the LocalStack endpoints, which are always these localhost 4566. The reason why this is actually commented out in this scenario is that we've recently created a small TF local utility, which you can use to deploy basically unmodified Terraform scripts against LocalStack, right? So this used to be kind of the old way of defining your endpoints manually, but using this new TF local utility, there's actually no more need to do this, and you can just go sort of straight with deploying the unmodified script to LocalStack. So before we take a closer look at what this actually does is, I'm going to switch over to my terminal here. So I have LocalStack started. I'm here in the sample directory, and I'm just going to do a tf local apply, which is the Terraform command to actually look at this at the structure of the template, and then sort of start applying the changes to the local environment. And it's just going to ask me, do you want to apply this? I'm just going to hit yes here. And while this is running, I can switch over real quick and see what this example actually contains. So we have a bunch of different resources here that might be familiar to you. We have an S3 bucket, we have an SQS queue, we have some IAM roles and policies defined here in this template. We have a Lambda execution role. So we also define a simple Lambda function. We can take a look at the Lambda in a second. And then also we define an event source mapping between the SQS queue and the Lambda function. So whenever we put an item to SQS, it is going to call the Lambda function. And then ultimately what we're also going to do is we want to try an S3 bucket notification. So the bucket is actually connected to the SQS queue, and then sort of that will call the Lambda function. All right, so switching over here, again, this is now deploying. So some resources like S3 buckets take a bit more time to deploy in the real AWS environment. So Terraform is sort of looking for DNS changes and so on. So that's why the provider is taking a bit more time to deploy here. But this should finish in a second, and then we have it ready. But just to summarize again, what we're deploying here is a Lambda function, an SQS queue, and an S3 bucket, and we'll connect these three together. And just looking quickly at what the Lambda function itself is doing. So the handler is literally just a console log, hello from LocalStack, and also going to print the events that comes in as part of the Lambda invitation. All right, so now it's we deployed. So what I have next here in my script is, so we've done the init, we've done the tf local apply. So the next thing we're going to do is we're going to send a.
I have a small query.
Excuse me?
Sure, go ahead.
Yeah, sure. So basically, you showed that the different services can get started, right, using test.tf, right? So I wanted to understand, like, all the services of AWS will get started on the same code.
Yeah, that's a great question. So, so by now we're starting all the services on the same port, which we call the edge proxy. It's kind of the single entry point into LocalStack. So you'll see this here in this configuration. It's always 4566. So basically you can you know, always run any API calls against this local endpoint, and it's basically a single entry point into LocalStack. The same is actually also happening if you run these AWS local commands. So this is our command line for interacting with LocalStack. So for example, if I do an AWS local S3 ls, I can just list the buckets locally. And what this command line is doing, it's also contacting this port 4566 that's running on your local machine, and then just basically extracting information out of it. I hope that answers your question. Otherwise, feel free to follow up.
Yeah.
Okay.
It answers. Thank you.
Great. Thanks. Right. So yeah, just sort of what we want to do now is, so we have this SQS queue and the S3 bucket and the Lambda function deployed. So what we would like to do now is send a message to SQS, and we just, you know, again, can use this AWS local command line to send a message. And what this will do, if you remember, we had this event source mapping between SQS and Lambda defined in the Terraform script. So what actually happens here on the left-hand side now, you can see in the LocalStack logs, is actually calling the Lambda function. And we see now between the start and this end log line here is the actual invocation of the Lambda. So this looks very similar to what you see in real AWS, where you have the CloudWatch logs of your Lambda. Basically has the same format here, and you see the output of what's been printed in the Lambda handler code. So that is was easy enough. Then we can also take a look at the logs of this invocation. So we can describe the log streams that are defined in our instance, and here we get the log events for this particular. So I need to copy this from here. So we can also get the logs in a programmatic way directly from the API itself. I just need to copy the log stream in here, copy paste it in here, and then we should get the individual logs from the API. Those are the same ones that we see here on the left-hand side, right? So again, like fairly similar experience to what we're used to when we work with the real cloud, but just it's all executed locally. The other point I wanted to quickly show is, so we've done now an SQS queue which invokes the Lambda function. We can also put an object to the S3 bucket. So let me just do an AWS local S3 copy command, which is going to copy some local file into our S3 bucket here. And this is again sort of now, you know, uploading the file to S3 in our LocalStack instance. That's actually then putting a sort of an item on the SQS queue, because we have a trigger on the S3 bucket, which then again calls our Lambda function, which you can see here in the ultimate output, where we actually get as the payload the record of the bucket that was just modified. So this kind of shows you just basically how these integration between the services work, and the nice ways that you can really iterate quite quickly on this locally. Cool. All right, so this was essentially the first part with the Terraform integration. Another thing you can briefly show is the web user interface. So that is essentially our like a visual, a graphical way to interact with your LocalStack instance. And so this is if you go to app.localstack.cloud, you can also sort of sign up for an account there. And one of the things we provide in there is so first of all, you see a dashboard with some basic information about how your instance has been used. And then also we have this part that we call the resource browser that has essentially a way to navigate what is sort of happening inside your local instance, right? And that's here we can see this bucket which is created and the object that we put in there. So again, relatively easy way to interact with the system, just having a graphic representation of it. We can actually share some more on this later. Cool. So that was the first part. I want to just show maybe two more quick demos. One is Lambda Hot Reloading. So one thing that you will frequently come across is, you know, the ability to make changes to a Lambda function locally and then really see the impact immediately. So how what is the change that you've made in your file without having to redeploy it directly to the cloud or locally. So what I'm going to do is switch here to my sample 2. And we'll take a look at what this looks like. So the sample 2 is basically a a simple Lambda function. This time it's a Python Lambda. So before we had a Node.js, this time it's Python. So we support different languages there as well. And it's just going to print a simple message, hello from LocalStack. Just going to zoom in here a little bit so you can also read this from your screen. So just going to print hello from LocalStack, and then basically return. So we don't call this buckets for now. Now what we're going to do is we're going to create the Lambda function again with our AWS local commands, but this time we're using a special marker name for our buckets, which is __local__. This is just basically a way to tell LocalStack that we want to mount the code for this Lambda function into LocalStack without having to kind of redeploy it, the function itself. So what I'm going to do is just create that the Lambda function here. And again, what this is basically doing is creating the function definition in LocalStack, and it's using the code from the local file system and sort of uses that code to run the Lambda function in the Docker container. So if we now do an invocation, we should, we're just going to call it AWS local lambda invoke with that function name. We'll see on the left-hand side again on our LocalStack output that the function gets called. Just gonna scroll down here a bit, right? So we can see hello from LocalStack. That is what we've been expecting. And now what we can do is we can go back to our Lambda, to our handler, and just say, hi folks, just make some changes, and without having to do any redeploys, just sort of invoke the same Lambda again, and then we should see the output immediately reflected in the second application. So just gonna a second there. And as you can see, this is like a very convenient way to kind of iterate quickly on your lambdas of the local machine. So what you can see here now is this hi folks, which we just added before. We can also maybe now include this list buckets call, which is not doing nothing but sort of listing the current buckets that are deployed in the instance. So we just add that in here as well, to another Lambda invocation. So you can see it's relatively easy to do quick iterations and cycles for making changes in the Lambda, see what changes, what the outcome is, and then kind of really not having to redeploy to the cloud every time you make a change. So here we can see now the bucket that is deployed on the local machine.
So Valdemar, I have a question. Can you open up the Lambda function for a second? I can see that you're calling Boto from inside the Lambda. Can you tell us a bit about how that works? Because if I call the Boto client, it should talk to AWS, right? How is it communicating with LocalStack?
Yeah, that is an excellent question and observation. So basically what happens here is, and this is something that some of you may be familiar with, is that Boto 3 actually allows you to specify an endpoint URL parameter. So usually what you will do is if you have a Lambda function, you could point that to something like typically what we do is like the LocalStack host name, and then let's assume it's localhost and then port 4566. But what we do in this particular environment, since I'm actually starting up the pro version of LocalStack, this is already taken care of. So basically, when you use just a regular Boto 3 client, we'll do the wiring automatically for you in order for Boto 3 to make the call to LocalStack. So yeah, but that's a great observation. If you want to have sort of the freedom or the flexibility to change the endpoint directly, you can use this endpoint URL here. But otherwise, we also provide this convenience feature where, especially in the pro version, we don't need to change the client at all. Yeah, that's a great point.
And some folks are some folks are asking whether the hot reloading feature works for for other platforms as well, or just for Python.
Yeah, great question. So it does work for any interpreted language. So Node.js, Python, I think there's even PHP lambdas, if I'm not mistaken. For compiled programs, like for example Go, it is also possible. Essentially, you will just have like a compilation step before, and then sort of like conceptually, it's just mounting the local directory into the Lambda environment. So there's really nothing sort of, there's no restrictions per se in terms of what runtime this can support.
And what about if I'm using, let's say, CDK or something to define my lambdas? Can I use this as well?
Yep, that's also a great point. So in CDK, we do, if I'm not mistaken, actually have a configuration option that allows you to specify as an environment variable that you want to use the locally mounted lambdas as opposed to sort of the real deployed zip files. So what CDK is doing under the covers is basically creating these assets, these zip files, and then like a CloudFormation template. But what you provide in this CDK local script is an option to leverage this local cloud mounting. I have to look it up in the documentation. I think it's hopefully somewhere in our docs, but maybe also Harsh and team can actually follow up with a link to the documentation there.
Awesome.
Yeah, that's definitely
Thanks.
something. Yeah, well, great. It's actually great to get some feedback and questions also on the live demo, so we know where you are and what the common questions are. All right, so this was the hot reloading part, which really kind of showcases the quick local dev cycles. The third part, if we still have a bit more time, would be a CDK. So now actually we're coming to the part where we're talking a bit about the Cloud Development Kit.
Yeah,
so
let's do it.
is
enough time.
Yeah, thumbs up. Okay, great. So the CDK is an offering by AWS that essentially is providing a language agnostic definition of your stack, and then particular language bindings. For example, you can define a TypeScript program or a Python program that defines your infrastructure stack just in a declarative way. Then there is the CDK compiler, as they call it, where you can basically synthesize from this CDK program a CloudFormation stack. And then CloudFormation is actually being deployed onto AWS. So it's kind of a bit of a multi-step process here, but the idea is that it's very convenient to provide essentially reproducible and reusable constructs here in CDK, which can be really easily sort of combined and deployed together. So what we want to show is a short demo where we deploy a CDK stack that uses an AppSync. AppSync is an API that basically uses GraphQL schemas and different mappings to data sources, for example, DynamoDB tables, RDS databases, or Lambda functions, and then kind of allows you to run GraphQL queries against these backend data sources. So what we'll deploy here is a simple example where we have a DynamoDB table and some query and mutation types in GraphQL, and then we'll just send a few commands there to get this deployed. All right, so this is the sample number 3 now. So let's take a quick look at what the stack looks like. So this particular CDK program is written as a TypeScript stack. So you can see here the typical structure of this. So it's called CDK demo stack. And then you can see a whole bunch of different constructs that are used here. So we have GraphQL API definition itself. We have an API key for the GraphQL API. We have our schema definition, which is sort of mostly made up of the query and mutation operations. So we'll just add a way to sort of query the documents in the database and then also save new items to the database. And then we also have the actual table in DynamoDB, which sort of stores the data. And then we also have the data source mapping, which is defined by AppSync. And then finally, what's called the resolver. So the resolver is basically the way to tell AppSync how can you actually access the data from the backend data source from DynamoDB. So this is all sort of fairly standard sort of AWS AppSync code. And what we're going to do now is we will deploy this as it is verbatim to LocalStack. So I'll go back to my sample 3 folder here. And so as has been briefly mentioned, is we have this CDK local wrapper script, which is basically simply a wrapper around the actual official CDK CLI, right? So they have the same command line interface. And what we can do now is we can, first of all, run a CDK bootstrap. So CDK local bootstrap is the the command used to bootstrap the stack. So this is required for certain CDK programs that have kind of shared resources or certain CloudFormation template requirements. So there's basically a two-step process. First, you do the bootstrap, and then do the deploy. So now it's running the bootstrap, and you can see again through the terminal output on the left-hand side, it's just communicating with my with the LocalStack instance here. So now this is basically deploying a CloudFormation stack that has a bunch of meta information and an S3 bucket, for example, where the CDK program will get uploaded. So this is kind of really preparing the environment for the actual CDK program then. Once that is done, the bootstrap interface, you also see here that it's using the account ID that we use for local. So this is just sort of a bunch of zeros, I think 12 zeros concatenated, and the region that we're using here, which is US East 1, the default. All right, so the thread is running, and we can then take a look at what this is doing. Give me a second to deploy. Usually at the end, it will just let us know that the stack is deployed. I hope you're also actually observing. I see that there's a bunch of chat messages, but I think Thomas and team are actually observing also what's happening from the question side.
Yeah, trying not to distract.
I think it was. Okay, that's great. All right. So. Okay, Zoom window is getting in the way here. Okay. All right, so the bootstrap is now done. So now we can do a CDK local deploy. And again, this is sort of now compiling that script that we saw before. Here, there's this TypeScript program into a CloudFormation template. This is all done by the regular CDK library, and then it deploys it to the local instance, to LocalStack itself. So now it's been synthesized. Now it's asking us, do you really want to apply these changes? We just want to say yes. And now it's deploying this change set. We can see it's now updating progress. Basically, the stack is now being updated with these resources. And then in a second, we should see stack deployed. What we'll do next is, I'll show it quickly in this script that I have here. Once it's deployed, we can then actually interact with this AppSync app that we've just deployed. So again, we're going to use the AWS local command line. Right, just wrapping up the deployment here. And again, you can use sort of, if you happen to use lambdas in your stack, you can just use sort of the same mechanism that we saw before with the hot reloading. It's just sort of a way to deploy your infrastructure using these CDK templates. Okay, so now what we can do is we can list the GraphQL APIs, and we can see, okay, so this has now been deployed. So we get an HTTP endpoint, and we actually also get a WebSocket endpoint, which you can use for real-time updates. And also it specifies that it's using API key authentication, and an API key was actually generated as part of the CDK stack. So what we'll do is we'll get the API ID. So I'll just sort of extract that API ID. Do an echo API ID. That's the one that was just created. Then we can get the API key. It's just doing another AppSync list API keys to extract the latest API key that was created. I'll also print this here, API key. And then we can run commands against this AppSync endpoint, right? So this is now where we actually really run a GraphQL operation. In this case, it's a mutation operation. I hope you can actually read this. So this is a mutation where we do a save with a new item with the name test1, and we return the name and the ID of this new item. So I'm gonna call this, and you can see here on the left-hand side, it's actually making the round trip to DynamoDB, and what we get back is basically the ID of the new item that we just added. And we can now sort of do that and interact with this GraphQL endpoint. So I'm gonna just add a new another item in here and extract the item ID. So we can do echo item ID. And then we can also retrieve it with the reverse operation, which is the query. So we just did a mutation operation. We can also do the query to actually extract a single item from the database, which I'm going to do here now. You see that this is the one that we get returned. So kind of really showing a bit more complex example. Again, to summarize what we did is we deployed a CDK stack, just one that you would usually use also in your AWS environment. Has a bunch of resources defined here, GraphQL APIs, data sources, resolvers, and then we actually run these GraphQL queries against LocalStack to extract the data. And we should now also be, if we just quickly switch over to our DynamoDB section here, we should also be able to now inspect actually the items in our table. So we can just do a quick scan here, and then we'll see, we got our test 1 and test 2 that were added before. So this gives you kind of a nice way to quickly interact with it and see what has been added. All right, that I think from the demo part kind of concludes that part. So again, happy to take questions afterwards, but I think with that, handing over back to Thomas for the next part.
Yeah, thanks, Waldemar. We should definitely do this more often. People are really interested in this, and we have so much to show. Probably do like a dedicated demo session event or something. I'm also curious. So what I hinted towards in the beginning is that we're trying to ramp up our efforts with community building. We're also interested in like how you guys are using LocalStack. So if you have sort of an interesting use case that you're using at work or you've developed on your own, and definitely in the next event, give room for people from the community to show off their work. And we can follow up with some more demos of what LocalStack can do. All right, thanks. That was awesome, Waldemar. I'll hand over now to Gerda to talk more about advanced use cases and how you can use LocalStack in your enterprise.
Thanks, Thomas. Let me try and share my screen here. So thanks a lot again also to the current presenters for the demo. That was, I think, very, very helpful for the community to really learn how to really get started with LocalStack, what our base offering is. What I'm going to show you next now is just a bit of a kind of summary and overview on what we already hear from our customers, the use cases, and some of the things that we are starting to work now going forward more and more. I'm having a bit of an issue with sharing my screen right here. I don't know exactly why. Maybe, Thomas, if you could just continue sharing and
Sure.
yeah, thank you. Yeah, so basically in terms of customer feedback, what we keep hearing a lot from our customers is that they're using LocalStack as the main use case for increasing their agility and efficiency in their development flows. So everything from increasing the reproducibility of everything that is going on your local machine to really at the end of the day speed up the entire testing and development cycle. And with that, what we often hear is that they're really improving the quality, because as it becomes easier to test, the teams are testing more, and really it's refreshing to see that we can basically really redo the way how people are developing applications and giving them a tool to increase developer efficiency. What we initially thought, obviously, was that cost saving would be a big reason why to use LocalStack. And what we see is that a lot of people really start also really jumping on LocalStack, trying it out because of cost reasons, because they don't want to use AWS directly. But we're hearing more and more that this is not like the #1 priority for our, at least enterprise customers down the road, because those productivity gains are their main focus. Another big thing, as I said, is that you can use LocalStack in very regulated environments. So when there is a lot of process up to really get any access to the cloud, and also a couple of companies are using it to teach cloud development. So basically, whenever new devs join the company who shouldn't be getting access directly to the cloud environments, a very easy way to get started is just deploy LocalStack and teach them how to get started. And in general, this rapid experimentation that is enabled through LocalStack is also a key benefit that it's often mentioned to us, especially when new innovation projects need to be launched, and there needs to be a way to really get your environments up and running and have everything in the organization without having to go through too many risk assessments and so on. It's a very easy way to just get started with LocalStack. So this is the main things that we're hearing. And Thomas, if you can go to the next slide, please. In general, our what we're now focusing more and more, as I said, team collaboration is something that's very dear to us, is now a new collaboration pattern. So we call it local cloud pods, and this basically really is a persistence mechanism for you to have shareable sandboxes of your AWS cloud environments that you're creating locally and can share with your team members, colleagues across the CI/CD pipeline. So as you can think about this really as a way to do branching, versioning, very similar how you work also with Git objects. You just basically have it now with your entire application state of your LocalStack instance. If we go to the next slide. So this obviously is, this concept of local cloud pods is obviously very helpful in the context of working with your team members and colleagues, but it's also very helpful when you integrate it into your entire CI/CD environment. So you can now easily integrate LocalStack with your CI system and its entire build jobs that are running there. So your test and application code would be part of the CI/CD pipeline together with a LocalStack container. And the LocalStack container can then pull the latest state into the CI pipeline from this cloud pod registry that we would offer here. And that really can allow you to do multiple test scenarios in your CI pipeline in a very easy way. And this concept obviously also allows to ingest the state actually from your production environments and using it together with test data directly into your CI environments. So there are a lot of possibilities and opportunities here to use LocalStack in a broader team setting, in a broader enterprise setting. If we go to the next slide, what we're now also focusing on is CI analytics, and we have a new feature that is called CI time travel. I don't want to go into too much details for that now. So if you're interested, obviously we'll be happy to set up a follow-up call. But in general, what this allows you is to really have a way to browse the entire state and the difference between one execution run to another of your CI build. So basically a historical analysis of your CI builds while you have the entire state available of what happened in the past. And if we go to the last slide, from my side, I also just quickly wanted to touch upon our Cockpit, which is our latest product that we have released. It's an Electron desktop app that basically lets you manage your LocalStack instance. So it's very easily accessible via the tray icon on your PC, and you can control LocalStack basically from your desktop without having to go through too much fuzz with either the command line, if you're not very familiar with that, or having to open our app in the browser. So you can easily start and stop your LocalStack instances from this Cockpit overview. You can see the current state of your LocalStack instance. You can basically see all available services, your current runtime, do initialization checks to see if your setup is correct and so on. So obviously it also offers you links to our website documentation, so you really find all the answers that you need in one quick and simple spot. And obviously, this is also now available for our community, but as a beta version. So I just want to highlight that again. It's a beta product, so we will push a couple of new changes. So always stay tuned and then check back for the latest changes on our Cockpit, which will come in the next months. And with that, I want to give it over to Harsh.
Thanks, Gerda. So yeah, I'm happy to introduce Harsh, our community DevRel, who will tell you a bit about our efforts to build out the LocalStack developer community. So take it away.
Hi everyone. My name is Harsh, and I'm the developer relations engineer over here. So as Thomas, Gerda, and Voldemort have already mentioned, our entire community version is pretty much open source. So if you're interested in getting started with LocalStack and maybe give back to the community, the best way of doing that would be contributing to LocalStack. Again, it's pretty much optional, but right now we are building up a contributor space from diverse backgrounds. And having all of you contribute to this, not just in form of code, but also documentation, examples, small bug fixes, or even just giving out a shout out for the community and the product will count as a contribution. So the best way to get started would be to navigate to our GitHub organization. I'll just drop the link over here, and you can check out the various projects that we have right here. If you're someone who is coming maybe as an engineering manager or as a developer who's trying out LocalStack, the best way of contributing would be to just make examples for us, and we would be more than happy to have them integrated to our repositories. We also have a community page where you can find all of the references, all of the external content that has been created by the wider LocalStack community. And if you have written blogs on this, or if you have created some YouTube videos and more of them, you can just send a PR to our website, and we will have we will be more than happy to have them integrated over here. So I guess it has already been discussed before on the chat. We have free education licenses, and it's for students and educators to try out LocalStack. I see that Thomas is smiling, so he's quite enthusiastic about it. But I'll just share the link once again over here so that you can reach out to us. You can send a mail to info@localstack.cloud, and we have a very simple form that you need to fill so that we get to know that we get to verify your status as a student or as an educator. And we would be more than happy to extend your license if you're still continuing in the same role. So I'm just dropping the link over here. And finally, we would be more than happy to have you on the Slack channel. If you are using the community version, the best way of navigating around the Slack community would be to just use the community support. You can drop in all of the questions, all of the concerns you might have, or any sort of feedback or reviews. If you're a pro user, or if you're planning to switch to a pro version, the best way of going forward would be to create a ticket for the LocalStack support bot. And we would be more than happy to help you on the whole process and make sure that LocalStack is the best fit for your product and your engineering team. And again, if you're not joined our meetup page, just sign in over there, and we will send you regular reminders about any future community events that we might be organizing. So thanks again for all your participation. It was a really successful one, and I'll hand over the mic to Thomas.
Thanks a lot, Harsh. Glad to have you on board to build up our community. So just some closing remarks, and then I'd be happy to have a bit more Q&A, because there was a lively discussion. We have another set of Q&A participation with Slido, but we can do both the Slido Q&A and the Zoom chat. But just a few closing remarks. So what can we expect from LocalStack in the future? So as Gerda hinted towards in the beginning, we've been sort of flying a bit under the radar as a company. We're now building out the engineering team, and we have a growing number of full-time engineers working on LocalStack. There's been a lot of activity in the LocalStack core code base over the past months. So if we put in a regression for you, or you experienced problems with the newer versions, then I really sincerely apologize. But it's for the better. We've been doing a lot of reworking of LocalStack internals that will allow new advanced features, and will just improve generally the robustness of LocalStack. So now that we have this first iteration, we will have a second iteration to make LocalStack more robust for your use case. So please bear with us. we have, a growing list of services and features of AWS. We're mostly focusing on AWS right now. So we're building out our set of core APIs for LocalStack. And we're adding, as Gerta already showed, more and more power features that you may be interested in using in your organization. Things that we're looking into for the next months are things like advanced IAM policy development, testing and developing of IAM policies, multi-region support. So we're going to improve that. And obviously, we're always keeping GCP and Azure on our radar. We have a closed beta for Azure, but we're sort of focusing on AWS right now. So you're going to see a lot of activity over the next months in the LocalStack core repository. Now's a good time to join the community. There's a lot of things to do in the repository, which are low-hanging fruit. So if you want to get involved in developing LocalStack, please reach out to Harsh or me. Yes, IoT, just because I'm seeing it right now in the chat, is something that we have support for in LocalStack Pro, and we're currently also iterating over that. So I guess, as I said earlier, stay tuned for our next event. We look forward to getting your feedback also on the event. We've had some good feedback so far in our Zoom chat. Thanks for participating. We'll post the next event on our meetup page. We'll also let you know via the newsletter. If you haven't signed up yet, you can go to our website, sign up for the newsletter, and be sure to get notified when the next event's happening. I could conceive that maybe for the next event, or maybe for the one after that, we'll have someone from the community step up and show something. So if you're interested in that, stay tuned and yeah, keep engaged with us. So thanks very much. And I think that concludes our session today.